So hi, I'm Bert from Percussa, and I'm here with Celine, also from our company. So we make the SSP, which is I put them in shadow, which is a DSP module for Eurorack. It has 16 inputs and 8 outputs, and they support 3 sample rates: 48 kilohertz, 96 kilohertz, and 192 kilohertz, all at 32-bit resolution. And so you can route signals into the SSP and process them, and then back out of the SSP if you want. And it has a quad-core processor running at 1.8 gigahertz, so it's about 40 times the processing power of most digital Eurorack modules, which are based on the Cortex M4 processor. And so all the inputs and the outputs are DC coupled, -5 to +5 volts. And they support audio signals, normal CVs, triggers, basically any kind of signal. There is no preference or no difference between the inputs and the outputs. You can process whatever you like with it. You can also record into it. So there is 4 pages here. And so this is a global page where you can load patches. This is the screen where you can edit patches, so you can insert modules and patch them together here. So there is LFOs, wavetable oscillators, reverb, delay, bus modules, a MIDI module, about 20 different modules, I think. And then you can navigate here in the patcher grid, and then when you press the P page, you see the close-up view of the module that's in the grid. And then here you have a multi-track recorder where you can sample stuff into the SSP, and then you can use those wave files anywhere in the module. So you can use it in the wavetable oscillator, you can use it in the granular module. There's multiple modules that can load files, basically. Yes, yeah. You can take the card, you can put it in your Mac or PC, you can put the wave files on there, or you can take the wave files from the card that you've recorded and load them into the computer as well for editing. And so when you record something, you can also record DC signals, right? So you can actually record the joystick movement, for example, if you want to. So on the card, there's about 60 presets, 60 patches. And it also comes with a collection of wave files that you don't need a license for to use. They're a public domain, or recreated them. And so in this patch I have an 8-voice wavetable patch. So you can see here there is a first voice, this is a second voice, third voice, fourth voice, and so on. Yeah, basically I put every voice on a separate page, and in the grid there are 16 pages with 8 slots for modules. No, it doesn't have to be. No. Yeah, you can structure the voices however you want. You can put them wherever you want. It doesn't matter. The way the voice assignment works is through the MIDI module, where you can group a MIDI module into a voice. So when a MIDI note comes in, it goes around and it drops the note in the different modules. And that's how the voice assignment basically works. So you're completely free to structure it however you want. So so in this patch I've connected a planar joystick, so I can control so it goes into the inputs, and I can control the X, Y, and the Z of the wavetable oscillator with it. And so in the wavetable oscillator you can load any wave file that you want, and it will cut the wave file into pieces. It puts the pieces into 3D space, and then with X, Y, and Z you can morph between all the pieces in real time. So when you play it, sounds like this. Of course, you can use any signal to modulate. It doesn't have to be a joystick, right? So if I take something else, like let's say I connect this to like Dixie or whatever, which is right here. I can like connect it to a function module from make noise. So you can of course also manually change the parameters like this. Then you can recut the file in real time like this. So depending on how you cut it, you'll get different timbres when you then modulate it. And then obviously you can go in the list and you can load any file without really having to think about it. Go in here and load something. Now you have a different file. So it's just as simple as pressing a button. So you can plug in whatever MIDI controller you want. So the SSP has, well, as long as it's MIDI class compliant, of course, but the SSP has 2 host ports and 1 device port. And so the middle port is for connecting MIDI controllers. And then the leftmost port is a high-speed port where you can plug in a USB Ethernet dongle. So if you're a software developer, you can log into the Linux system that runs on it that way. Or you can transfer files over the network that way. And then the device port is used for streaming audio to your computer. So you can also connect it to your computer, and then you can stream stereo sound in real time at different sample rates into your computer. And we're working on an upgrade where you'll be able to actually stream all the channels over USB 2. Yeah, right now you have a stereo pair that is streamed over USB, but it's going to change. It's going to change into 8 or 16 channels with on the coming updates. It's sending the first 2 output channels, basically. That's what you get. Yeah, inside the patch you could route from the input module, for example, here to the output module, and you have that. So like the input module is where you can see all the signals that are coming in. So you get scopes for every input, and then when you go, every time you go left or right, you basically go to the next row of inputs. So if I connect something on the second row, now you see the signal from the STO. And then the input module has like summing built into it. So like when you enable these toggles, it will sum those signals. So like it's virtual output 1 that I have enabled now for the first signal, or like, you know, for the second signal. And like, so if I have on the first row, if I have this, and on the second row I have this, it's basically summing those 2 signals together. So you get some of that functionality in here too. And then, like, for example, there's an envelope. Obviously, you can change the parameters of the envelope like this, if you wish. And you can also group the parameters. I mean, you can group the envelope such that when you turn one of the parameters, it will change it on all the voices. So that way, you don't have to go into every voice and change the settings of every envelope in every voice, basically. Makes it much easier. And so about the modules, some modules only have 1 parameter page, for example this one, but others will have multiple pages. So when you go left and right, you can access additional parameters. Yeah, that's kind of it for this patch. So I'll go to another one. I have some more polyphonic stuff. Yeah, that. So this is a patch where you have multiple granulars and multiple oscillators which are configured in an FM pair. So of course you have a delay and a reverb, or actually just a reverb in this one. But so in every granular you have a sample that's loaded, and you have an envelope for the granular and an envelope for the FM pair. So this is the second voice, and then you have the third voice here. And so every module has a list on the left for all the modulation inputs it accepts, and then it has a list on the right for everything that it sends, combined with the inputs from the modules you've connected it to. So if you patch this, so by the way, patching between the modules is done with the shift left or the shift right key. So you navigate to a module, then you hold either this key or that key, depending on where you want to patch. Then you go like this, and now it's patched to that envelope module. If you want to undo it, just like this. If you want to patch to the granular, you go like that. Now it's connected to the granular, and on the right-hand side, the list updates for the possible combinations. And you can decide to send, for example, the sine to the granular. Let's see what we want to do. I don't know, like pan or whatever. And then here in the granular, you would enable the panning. And now you see a little 1, which means it's getting one modulation signal. So that's how the patching basically works. So there's always the step of connecting the two modules and then deciding what modulation signals the modules are sending and receiving. And so when you disconnect two modules and you connect two different modules together, it will reevaluate that, and it will connect like 5 signals or 6 signals or whatever, depending on which inputs and outputs you've enabled, which makes it very quick if you want to try combinations of different modules and you've enabled their inputs and their outputs. You'll get like, it's like connecting multiple patch cables together and disconnecting them. So there is another polyphonic patch, which is interesting to look at. Remove these modulations. So this is kind of like a Oberheim style subtractive patch, where again here you have the effects section. So there is a bus with a delay and a reverb, and then here you have the voices. So again you have 1, 2, 3, 4 voices times 2 oscillators. Then every oscillator has multiple outputs. So every oscillator has like sine, sawtooth, square wave, triangle, and then the inverse waveforms. And so in this patch, I'm using sawtooth as well as square outputs. And you have the envelope which controls the oscillators, and then you have a filter, and then it basically goes to a bus. So the different voices are summed together in a bus, and then the bus goes to the effects section. That's kind of how the patch works. And then I think you can also, so the input module is used for modulating the filter here. So you can see it goes to the filter cutoff. And also to the FM input of the LFO. Any questions, by the way, about the patches? Let's see what else we have. $2,000 retail. You have to ask Sean about that. You have to ask Sean. That's beyond my control. Sean will tell you. So this patch is again combination of FM and sampling. So there is also a sampler module, obviously, where you can just load samples and play them back and trigger them with gates. And so the sampler module has 8 slots. So you can load 8 files into it. And then every file can have 8 channels. So you can play back 8 channel files. And then you can choose whether the channels are summed or not. So you can with this multi-channel button, you can decide whether you want to sum all the channel 1s and all the channel 2s and all the channel 3s and all that, or if you just want to output the first channel of every file in the grid. So here in the grid, on the right-hand side, you have output 1, output 2, output 3, and so on, if you scroll. So the every sampler module has 8 outputs, and you can have, of course, as many sampler modules as you want. So you can build whatever synthesis structure you want. And then there's also a crossfading feature in the sampler, which you can access here. So if you turn this, you'll see these green lines moving, which changes the crossfading region, basically, when you play back. And of course, on the input side, you have a pitch input for pitch CV, which could come from a keyboard, or it could come from the MIDI module here, which is able to send you like a virtual pitch signal for every note. And there's a start input for modulating the start. There is a gate input for triggering the sample. There's a length input for changing the length of playback of the sample. So every slot has different gate inputs for triggering the different samples, as well as all these different modulation inputs, basically. So then so this is a patch where you have different samples, 8 samples, 8 percussion samples, and you have a step sequencer, and the step sequencer is driving the sample, it's triggering the samples. But there's also a switcher module in the grid, and what that does is it uses the step value to decide to which output to send the gate for the sample. So in the step sequence, the height of the bar decides how to route the signal, the gate signal which triggers the sample, which is in the sampler module here. So if you change this, you get the idea. Then of course you can also mute certain steps. You can turn off the gate, Then, similar to that, so this is a patch where you have a step sequencer, and it's driving 3x4 oscillators in like an additive synthesis arrangement. And then every group of 4 oscillators has an envelope as well. And so if you go to the step sequencer, you can turn on different notes. So let's see what else we have. So this is a physical modeling membrane module that you can, of course, trigger in all kinds of ways. I mean, there is a gate input. There is a power and a tension input, so you can modulate 2 parameters of the membrane as well. So I can use this square wave. So now I'm triggering it just with a square wave from the Dixie. And then the tension and the power is being modulated by these 2 noise generators, which are running very slowly. So they output continuously a changing level, as you can see. We're working on other modules as well for physical modeling, so we might do like a car plus string module and some other stuff as well. So this is one we have right now. So another interesting patch is so this is a 4-voice step sequencing plus microtonal quantization patch with, for every voice, a sine wave oscillator. And so what happens is you have these sequences and they go into like the microtonal quantization module. And so in this module you can load any scale you want from the Scala archive, or you can make your own scales as well in the Scala format. So there are about 4,500 microtonal scales which you can download for free on the website of this organization in the Netherlands called Stichting Huygens Fokker, I think. And they have all these scales, and you can download them and you can put them on the card and you can load them, and then you can quantize pitches from anywhere, from outside that you bring into the SSP, or from inside, from the from the step sequencer or whatever. And so what it does is, it will, when it loads the scale, it will use a root node which you can set here, and it will use the root node together with the ratios from the scales to create like a frequency map, which you can see there's all these lines drawn vertically, and then every time you get a change in pitch, it converts it into a frequency, it quantizes it, and then it converts it back into a pitch. And in this case, the pitch goes to the sine wave oscillators, but you could just as well send the pitch out of the SSP and then control an analog oscillator. That works well as well. So yeah, so that's basically what it is. There's also an input module here, which you can use to frequency modulate the oscillators, I think. Let's see. So in the list of the modules, we also have a envelope follower. So what this is you have a drum sample, drum loop, and the drum loop goes into the envelope follower, and then the envelope follower controls the filter, which is an analog model filter. It's a state variable filter, but there's an analog emulation built into it. And then you have a sawtooth going through the filter. So that's what you're hearing in the background, basically. So it's a very simple demo, but it shows that you can take signals, make an envelope out of it, and then either send the envelope out of the SSP or control stuff inside the SSP. So this is a very simple patch. You just have an output module, you have the granular, and you have an input module, which you can use So, which allows you to bring signals in to modulate the granular. So, for example, input module is going to the start as well as the length. Yeah. So right now you have this sample running. So in terms of parameters in the granular, what do you have? You have the length of the grains, which smooths out the sound. Then you have the trigger frequency for the grains to get more grains or less grains. You have a level control for limiting the level, for reducing the level if you need to. And then you have a tuning knob for pitching it up or down. You also have a manual pitch knob. You have a dub and a blend knob for when you use a live input. So when you use a live input, you can record into the granular and you can overdub it. So with the dub control, you can decide how much new signal you want versus how much old signal stays in the buffer. And then with the blend, you can blend between the live input and the granular. And then with the pan, you can manually pan the signal, and with the pan randomization, you can decide how much you want it to randomize the grains. So how much grains go to the left speaker versus the right speaker. And then there's also a feature coming where you have 10 windows. So right now it's just a triangular window for the grains, but we have added 10 different windows in the new updates, and then you can morph the windows in real time. So you can morph between Hanning and a rectangular window. You have 10 different ones. I don't know off the top of my head. Kaiser window, whatever. All these different windows you can use, as well as a flat top, and that changes the timbre of the sound as well. With this you can erase the whole patch if you want. And so if you want to insert modules, that's pretty simple as well. You can do like this, insert the output module. So this brings up the catalog of all the modules. You have the output module, the input module, the bus, delay and reverb. You have a macro module, so you can, when you build a patch, you can insert a macro module and then you can connect the parameters of the macro module to the global. So when I insert this thing, and let's say you have something else like this granular module, and you would patch it like this, and you say, okay, M1 goes to start. Now at the global level, here you have these controls, which will control these parameters. So this way, you can create a patch where you have many modules, and with one knob, you're basically controlling multiple things in the patch. So what else do we have in the catalog? So there is normal oscillators, and so this is called LFO, but it's really a normal oscillator. It actually goes up to 20 kilohertz, so it's not really an LFO. I have to rename this module, but it's a normal oscillator. The reason it was called LFO is because it's not a band-limited oscillator, which means that it will alias if you drive it up real high. So there's a sampler, the granular, I've talked about that. There's the noise generator, which is actually has a frequency control as well. Subsequencer and quantizer, we talked about that. There's a comp filter, the envelope follower, we talked about that. Simple delay, so it just delays the signal, it doesn't do much otherwise. A wave shaper, a bit crusher. There's a VST host as well. So if you have Linux ARM VST plugins, you can load them. It doesn't load like your Mac or Windows plugins, unfortunately. So because we use an ARM processor, and that wouldn't be efficient. But if you if you like using Linux and you're familiar with that, you can use that for making your own modules if you want to. So there's an example that we give, like a quad VCA, and the source code is provided, and you can get it off GitHub, and you can use that as a starting template. So you can put your own DSP code in that, compile it, put it on the card, and then load it. And there's also a basic arpeggiator. Yeah. So a lot of stuff already, and we are adding more modules all the time in the updates. We've like averaged, I think, an update every couple of weeks, so it goes quite quickly. And there is also a forum, so you can join the forum and exchange ideas there. Oh yeah, the recorder. Yeah, I almost forgot about that. So back to this. They removed this sample for a minute. So if you go to the recorder and if you want to record something into it, so there's 16 channels for the input recorder you can use. And there is 8 channels for the output recorder. So there's 2 recorders, an input recorder and an output recorder. And the output recorder is what you can use to record like your performance or whatever. And the input recorder is what you can use for like if you want to sample something, I want to use it in a granular or a wavetable or whatever. That's what we use then. And so there is monitoring and playback capabilities as well, and some basic editing features. So let's say I want to record something, like let's say take this STO thing here. Okay, so I patched the output of the STO into this input of this LXD, which is like a low-pass gate, and I have like a square wave oscillator, which goes into the strike input, and then I take the output and I feed it into the SSP, and you can see I have some signal here on the scope. So if I want to monitor this, I turn on monitor, and then I go here, and I have to assign the monitoring. So I have to route the incoming signal to some of the outputs, 1 or more. There you go. So now I can record that if I want, like this. There you go. Now stop monitoring, and now I have this, and I can play it back. So I can go here and I can again route the playback channel, so it will play back on the channels I want. There you go. So now I can go. So by the way, if you record like a multi-channel file, if you then open the file on your computer, you get all the channels, right? So if you have recorded a 3-channel file, you will get 3 channels, but if you armed 8 channels, then you have 8 channels, and it goes up to 16. So if you have like lots of modules and you actually want to record all of them in parallel in a multi-track file, that's what you could do, basically. Or if you have a live show and like you're playing it quadrophonic or whatever, and you're doing it on the SSP, then you can record 8 or 4 output channels to a file, and then you can take it into a DAW, and you have all your tracks immediately, and you can start to edit it, basically. Yeah, it can be anything. So like if I decided to record the joystick, you can do that too. Go like this. So now I have the joystick connected to the inputs. Do this. Let me move the joystick around. Whatever. So now you have a file has the joystick movements basically. So if you load up the wave file into Ableton Live or Logic or whatever, you'll just see like a bunch of drawing basically. Yes, yeah. You would put this into the sampler module, and then you'd play it back, or trigger the sample module, and then you send the outputs from the sampler module using the output module out of the SSP, and then you feed it to some other module. That's how you do it. Yeah, there is like some basic editing features, so like you can like make a selection like this. You can zoom as well. And then you can do crop, reverse, normalize. And then when you're done, you can do save. So you have some basic editing features in here. No, there is no fades yet, but that's a good suggestion, and definitely something we'll put in there. Let's see. So yeah, so if you go back here and you say, oh yeah, I want to load this thing, there you go. Now you have this file that we just recorded. What was that one? Yeah. This is the one we just recorded. On the scope it looks a little bit differently because the drawing code for the scope here is different than the drawing code in the other scope in the recorder, but it's that file. And so now you can start using it. Yeah, and so the settings are normally wrap around. So when you turn it like this, it wraps around the range, and you can turn that off as well if you don't like that. So there is a setting in the global menu where you can turn this on or off. Some people love that, some people hate that. Yeah, I think I went to through the patches. Happy to take any questions or. Yes, yeah. I can go back to that patch if you want. Anybody else who wants to see it? Yes. So this is one of the patches where I've shown the step sequencer. Did you see this one or not? Yeah. Yeah. So here in the steps, if you go to the step sequencer, this is where you can create your sequences. So like if you go left and right, you can select 4 steps at a time, right? So I can go like here, and then when I turn the knobs for the steps, I can edit the steps like this. And then you can enable the gates like this for the steps. And you also have a second gate track as well. So the step sequencer has a normal step output, and then it has 2 gate outputs. So for, depending on which gate is on or off. And then you also have last in and last 2 outputs, and what that does is it will output the step that was there when the last time the gate was high. So this way you can skip over steps that you don't want to care about, for example. Yeah, so one thing I have to do here is I have to go in here and I have to make the pattern longer. Or I can make it shorter. Yeah, so the numbers you're seeing do not represent volts. They just represent the numeric value. So what happens is, when the signal comes out of the DAC, it's converted to a voltage in 32-bit resolution, actually. Yeah, so if you want to quantize this, like we did in the other patch, hold on, let me see. This was 52. So here you have multiple step sequencers, and they are being quantized by this microtonal quantizer module. So in the quantizer module, you can load any scale from the Scala archive, and then it will quantize your pitch. So you can either create your own scales, or you can download the scales. There's like, I don't know, 4,500 Indian scales, Iranian scales. Yeah, I have no clue. I'm not a microtonal composer, so I just put a couple of them on there, and that was already enough. But you can change the root frequency like this as well. And when you do that, it will recalculate the map of all the frequencies that it uses to quantize. And so you see in the display, you see the frequency, and then the quantized frequency and the root frequency and so on. Not right now, but that's a good idea. It's a good idea for a feature, for sure. Right now, it just has a pitch input, the quantizer. We started working on the synthesis engine about 10 years ago, and the hardware, we started working on that I think about 3 years ago, or yeah, something like that. Yeah, so with the SSP you can do a lot. I mean, even if you would build, like if you decided you want to build like a polyphonic, like wavetable synth or whatever, and you do it with like normal Eurorack modules, it would cost you like, I don't know, $10,000 or whatever. With this, you can do, you know, have this module for $2,000, so you can do all that. And you can still bring in other modules that you really like, that are analog or not analog or whatever. So you can like mix and match easily. Or if you find yourself in a situation where you really need another oscillator, you cannot like immediately drop everything and go somewhere, then the SSP will save your day, basically. Okay, you turn everything off. You take the card out, put it in your computer. You copy the file for the preset, and you upload it. It's right here. It's a vertical slot. It's a micro SD card. When you buy the SSP, you get a 32 gig card with it, and it's a special card. It's like an extreme card. So it guarantees that it can record 16 channels to disk if you record on it. In the update that's coming next week, there is no limit anymore. In this version of the software, there is still a limit, I think for a couple of minutes, but like in the update that's coming next week, the limitation is gone. So you can basically record until the card is full. And you'll also be able to edit those long files as well, and play them back as well in the recorder. Yeah, right now you have to power it up, but that's also power it down before you take out the card, because it basically loads everything from the card, you know, operating system, software, files, everything. So right now that's the case, but there is an internal 16 gig flash on the processor that we're not using yet, and we're going to be using that quite soon, and then that will be gone as well. But right now you turn it off, put the card in your computer, put it back in, turn it back on. Any other questions? Yes. Yes, yeah. So then the OS will run from the internal flash rather than the card. Yeah. Yes. Yeah. It will look for presets and files on the internal flash and then also on the card. So like all the stuff that we give you will be on the internal flash. I'm trying to think what else I can. I mean, is the patching system clear at all? Is that like how that works? When how you patch something together in the grid? I don't know if everybody saw that, like how you. So like if you so you just press this button to bring up whatever it is that you want. Let's say the sampler, and then like you take an output module. And now you have these two modules, and you have to patch them together. So you first navigate to the sampler, and then you hold the shift left or the shift right depending on where you want to patch. So so I want to patch to the output module, so I do like this. Now I've broken it. Now I've created the patch connection again. But now you have to tell the modules which inputs and outputs are enabled. That's step 2. So like you say, I want to send the output to the output module, input 1, and here I enable it. And now there's a little 1. So now it has created the connection. And what this allows you to do with this two-step process is if you have multiple modules and you want to break multiple connections or create multiple connections between modules, you can break the model connections, but then when you recreate them, they're all there again. So if I would enable like these 4, and here I enable them as well, you see this 4 times 1. If I break this, now it's gone. If I recreate it, now I have 4 connections again, and I just pressed 1 button. And that works with multiple modules. So like this, if you have multiple things that are modulating each other and you want to experiment to find out what happens if you like connect this to that, it will like virtually like pull out all these cables for you and then like reinsert all these cables for you, which in a normal modular thing you have to like really manually do all that. So it's kind of like semi-modular patching, you could say. So then you can like load your file. You like change this a little bit. Now I can crossfade it. There you go. So the green lines that you see, that determines the crossfade region. So that's basically how you patch something together. And then of course, you know, you can, let's say I want to modulate this with some other signal. You insert an input module and then you connect this to the sampler. And then you say, let's say I want to use this input to modulate the start position. I enable this, and then here I enable this as well. I have a little 1. Then I go into the input module and I take a cable. Now I see the Dixie signal here on the scope. Now you see the modulation. Well, what you would do is you would go into the input module and like what you do is like you connect this like that. Now you see the signal here on the second scope. It's a triangle. And now you can say I push button 2 because it's, you know, it's a second signal, so I push the corresponding button. And then here in the list I go and I say, okay, I find 2, and then I look for sampler length, like this, and then here I enable it one time. There you go. So that's how you do it. Oh yeah, you asked how you would sum it. Well, what I mean, when you find the same input here, the start, now you see there is 2. So it means it's getting 2 signals. So the 2 signals are summed automatically together. So and also what you can do is you can scale those signals. So on the left hand side here, you can select the input, and then you can hold this button, and then you can turn this knob, and it will scale the signal. So yeah, some right, yeah, yeah. So here you can scale it like this, or scale it down like that. And the same with the output signal. So if you want to like scale the output signal, you just select the corresponding output line, and then here you just hold this button and turn the encoder, and now you can scale the outgoing signal like that. So there is like attenuation and summing and scaling. It's all built into the grid basically. Mm-hmm. Probably. I haven't tried that, and I wouldn't know how to build one off the top of my head immediately. But I didn't know if you saw the envelope follower patch. So here you have the drum loop being played back. It goes through an envelope follower module, and then the envelope follower controls the cutoff of the state variable filter. And then you have an LFO, well, normal oscillator, sawtooth oscillator going through the filter, basically. That's what this patch does. Yeah, anything, yeah. So, yeah, people have been arriving and leaving, so I don't know what other, I mean, I have a bunch of patches that I went through. Has everybody seeing the polyphonic patches? Yes? Okay. Oh, well, so the SSP has 3 USB ports. There is a high-speed port for attaching a USB Ethernet dongle. So if you're a developer, you can use that to log into the Linux system that's running on it. So in theory, you can also stop our Linux software that's running onto it and put some other Linux software on there, like Super Collider, PD, whatever, right? Yeah, or like play Doom on it. I think you can do that too. But so that's mostly right now for developers, I guess, or for people who want to like hack into it, whatever. Then the middle port is for USB controllers. So when you connect the controller, it tells you that you've connected the controller. And then you have a streaming port, a device port here for streaming audio to your computer, Mac or PC. It only does stereo right now, but in the update that's coming, it's going to be 8 or 16 channels. So you'll be able to stream your inputs and or your outputs over USB into your computer. So then it's kind of like an audio interface at the same time with DC coupled inputs and outputs, which can be really useful. What is that? Yeah, so the converters support 48 kilohertz, 96 kilohertz, and 192 kilohertz at 32-bit resolution. So it's always 32-bit when you sample something. When you load a file, it pretty much supports all normal WAV files and also abnormal WAV files. It loads like pretty much all WAV files and all sample rates. No, only WAV. Yeah. I'm trying to think what else I haven't talked about. Yeah, if you want to save a new preset, like you've worked on something, you just do write new. Now you have a new, like if it's saved everything to a new preset, and then you can like rename your preset like this. You just go like that, and then you do write. And now it has renamed it, so it's pretty quick. There's also a factory reset button in case you want to recall your patches because you screwed them up or whatever. So the step sequencer. So you can drive it with a clock. So you can normally it has an internal clock. So yeah, sorry. So it has an internal clock normally, but you can turn it off, and then you can drive it with some external clock. So if I get rid of this, if I take like an input module, like I can feed it to the clock input, then here enable the clock input, and then I can like take this, I have this like square wave noise generator thing here. Take this out. Then I have to go into the input module. So now I have my square wave signal. I have to enable this. Now you can see it here on the scope, and here as well. So when you go into it, it's now being driven by this external clock signal, basically. So and then you could take an LFO and an output module, and you could like send the step output to the pitch input of that LFO, then connect the LFO to the output module. Wow, that's really loud. I don't know why that is so loud. Ah, of course, yeah. There is nothing yet in the step sequencer. Yeah, it's being controlled externally. Yeah. There you go. Yeah, there is a copy feature. I think if you have another step sequencer, I think you can copy between them. Oh shit, I erased my thing. Okay, whatever. Hold on. So I do copy, and then here, there you go. So you can copy sequences like that. No, that not. No. Good idea, but that's not there right now. But it's noted, and if possible, I'd put it into the software. So if I want to save this, I just go here, I do write new, and now I have a new patch. Not yet, but that's also something that is definitely planned. So what I'm gonna do soon is make a selection feature, so you can like start a selection and then go like this, and it will like highlight the region, and then you can do copy and then paste it, or you could go in here and select the patch, and then you can insert it here. So it will like be like a template. So if you have like an 8 oscillator template or whatever, you could like insert it in place basically. You can only play one patch, but one patch can be a combination of all kinds of things. Can be polyphonic, can be multi-timbral. There was a multi-timbral patch I played here. So this is a combination of FM and sampling basically. So you have these two FM operators, and then you have a sample. So it's multi-timbral basically, and also polyphonic, because you have 1, 2, 3 voices. With each voice, 2 envelope generators, 2 oscillators, and a sampler, and a MIDI module, and a bus module basically. No, what I'm scrolling through is through the patch. So this is basically like a long, like, yeah. So like you have 1, 2, 3, 4, you have 16 pages, and every page has 8 cells, and then in every cell you can put a module. And so on, what I typically do is on page 16, I put my FX section. So I put like a bus and a reverb and an output module. And so then in the patch, what I do is I feed the oscillators into a bus module. So you can feed something into the bus right here, and then you can take it out of the bus somewhere else. So it's a routing system that lets you like go anywhere in the patch without necessarily having it in view. No, you can also just go like this with the encoders if you want, like that. Any other questions? Yeah, one interesting thing maybe. So these oscillators also have a group feature where you can put them in a group. So when you turn the parameters of an oscillator, it will change it across all the oscillators in the same group, and you can have multiple groups. So you put some oscillators in group 1 and other oscillators in group 2, and like that. Like that you can build it up. And you can have, there's a ratio button. So if you're familiar with FM synthesis and you want to use certain ratios, then that's what you use. If you look at like a DX7 patch book or whatever, and it says like ratio 7 or whatever, then you can dial it right in. And the same with the detuning. Sometimes there is a detune parameter if you want to build an FM patch. That's very handy too. Then there is also, so the MIDI module also has a, so yeah, I haven't talked about that much yet. Actually, let me go here. So this is the patch that I showed when we just started. It's the 8-voice wavetable synthesis patch. That's being modulated, of course, right now, but. So the MIDI module has a pitch output, and so it takes the notes and it creates a CV from it, and you can send the CV internally or to module externally. So you could use the SSP as a polyphonic MIDI to CV converter, basically. Well, you have 8 outputs on the SSP, so you'd get 8 CVs out of it. And so the MIDI module has a velocity on output and a velocity off output and a gate output, so you get the velocity when there's a note on or a note off, and you get the gate from the note. And then you also get aftertouch, and you get like the typical MPE controllers, so it supports an instrument and a Rolly C board as well. So you can build polyphonic MPE compliant patches. And so this MIDI module does not give you access to any MIDI controller yet. It just gives you a selection, but there's going to be another MIDI module that I'm working on that will give you access to any MIDI controller, and then you can connect like a knob box and route knobs to whatever. Yeah. So here I have, for example, the mod wheel is connected to this wavetable oscillator Z. If I play it. No, it becomes part of the pitch signal. So the pitch band information is used together with the note, and it will automatically give you the CV, basically. For the pitch band? Yeah, right now that's like fixed because of the MPE support we put in. I think, I don't know off the top of my head how many semitones, but that's fixed right now. Yeah. So, but that's fixed right now, but we will probably make that a parameter in the user interface. Yeah, yeah. So you can change it if you have a different MPE controller. I mean, some are like this, others are like that. Yeah. MPE, I mean, and MIDI is like the wild jungle right now. So network page. Yeah, so you can copy paste modules. You can go like this, copy, paste. Now you have a copy of the module. You can clear the input list, or you can erase the whole grid. I mean, kind of obvious features, but no, not right now, no. But I mean, there is some code in the application for MIDI program changes, but I'm not done with that yet. So when that happens, maybe you'll be able to use a foot controller or something to switch your patches. Yeah, would be useful for sure. Yeah. Is there anything else you guys wanted to know or ask or see? What is that? Yes, for the two of us. My partner is right there. Thank you, thank you. Thank you. I'm glad you like it, thanks. The micro SSP, I don't know if we're going to do that. I mean, we launched it in a Kickstarter, and I told people up front that this is what we needed to raise to do it. And the goal was significantly higher because we basically have to design a lot more electronics to bring the cost down. So we have to redesign the CPU module and all that to cut the costs, right? So it was going to be like a $550 product with basically the same processor as the SSP. And we could only do that if we would raise enough money to buy all the parts, to bring the cost down. And that's why the goal was set at $120,000. We didn't get there. We got only up to 65,000. So it's unfortunate. You know, maybe we'll relaunch it. We don't know. Yeah, it was also launched over Christmas. Maybe people had other priorities. I don't know. Yeah, it's not. I mean, it's not off the table indefinitely, but we don't know if we would do it and when we would do it again. We don't know right now. Yes, or maybe we will simply skip that process and like do a pre-ordering thing on our website, or maybe we'll do something with Sean here and on Haven. I don't know yet. So, but we'll look into it. Yeah, or a combination. We'll find out. Here in LA. Yeah. Yeah. Right. Exactly. Yeah, yeah. Anything else? Oh, you're welcome. Thanks.